Welcome, everyone. This is the Tuesday, October 1st, 2024 session in our series on innovations in manufacturing and supply chain, opportunities and challenges in realignment. So I'm delighted that we've got a panel today of speakers who are all connected with innovation in the manufacturing process, especially design for manufacturing. Before I introduce our speakers, I've got a couple of words for students who are taking this for class. Remember, you are due to write a weekly comment to me within 2 weeks of today's date for this class today. I haven't been able to answer many of the comments from last week, but please be patient. I will get to them very soon. Also, remember that there are 2 requirements for credit. One is the weekly, and the other is to be in person or be present at the seminar in real time. So if we are having a Zoom only session, then that would mean being present during the Zoom meeting. We'll check your attendance using the Zoom record. But if it's in person, we really hope that you'll be here. At least today it's nice and cool in the auditorium, but after the session is over, we've got some light refreshments outside and would like to encourage you to stay around and get to meet each other, get to talk to some of our speakers and network in the Silicon Valley way. So one other comment for everybody who's watching this regularly. Next week will be Zoom only. We will not meet in the auditorium next week, but we will have live Zoom for a session with Dr. K.S. Choi from the Electronic and Telecommunications Research Institute of South Korea. And they have some interesting manufacturing technology that they are just commercializing. So today, our 3 panelists, I'll start closest to me. Stephy, Deng is the founder and CEO of Adofaer. Is that the right pronunciation? Is it close? How do you say it?
Adofaer.
Adofaer, okay. And Adofaer is a platform for transferring concepts into collectible toys. She will explain this more later. She's got a background in toy manufacturing. She's been a data engineer. She's been an application consultant for IBM. You got your undergraduate degree from University of College in London. So there's a UK angle. And I mentioned this because Ivo also has a UK angle. Next to Stephy is Timóteo, who's the founder of Braid. And Braid is involved with automation of advanced engineering design. So we'll talk to Ivo in just a few minutes about that. Before starting Braid, he was a principal lecturer of the AI2 class at Cambridge University. There's the UK connection. And at that point was invited to be CTO of a self-driving car company before he founded Braid. And furthest away from me is Asakura, who's the co-founder and CEO of Final Aim. And Final Aim is also about design for whole kind of manufacturing and supply chain management. We'll talk about that in a few minutes. Final Aim is actually moving your base, at least expanding a lot over here, having been in the Berkeley Skydeck, and now where's headquarters in the Bay Area?
As a Menlo Park.
Menlo Park, okay. Before coming to this area, he was working with Mizuho Bank. He worked with Recruit Company as the system project manager for the global planning department in Singapore, India, and Vietnam. He was living in Singapore for 3 years. And he's also the former COO of a company called Kobuku, which is AI and additive manufacturing, so 3D printing, that was acquired successfully in 2017. So we're going to go in exact opposite order for our panelists to give us some prepared remarks. And then we'll have plenty of time for Q&A. This is going to be very interactive today. So Masaf, why don't you take things first?
Okay, thank you for coming, everyone. I'm Masa, co-founder and the CEO of Finalware. My first exit is Singapore, and the second is Tokyo in Japan. And this is the third time as a CEO. Let me share first of all my story. Previous startup, additive manufacturing and artificial intelligence startup, I worked with a lot of professional designers, industrial designers, product designers, graphic designers, and interior designers. It was very fun for me. The reason why, simply I love design. I like design. Design is amazing. Only one shot. It's possible to sharing everything. So for me, to working with professional designers, it's a very fantastic and amazing experience. But some designers very struggle with working. The reason why, sometimes our intellectual property problem happened, and sometimes as a contract management problem happened. It's a costly, risky, and human intensive. What's the problem? Yes, I know the reason why. I have lots of experience working with professional designers. And what's the solution? Yes, I know. I am a serial entrepreneur. I know the technology, smart contract, and artificial intelligence. So 2019, I decided to launch a new company, Finalware. I came back a startup system. Okay, as before the detail about our company, let me share a more casual introduction for me. Once again, I'm a serial entrepreneur and I lived in Singapore 3 years. And after the Singapore, I participated in the previous startup, Kabuku. And it's my family. I got married around 12 years ago. And I love drawing and sketching and the Japanese manga and anime. The Naruto and Attack on Titan. And I love to read those types of manga every week. And my daughter is 10 years old. She likes drawing and the sketching. It's my family. And as Dasha-sensei said, I'm alumni of the UC Berkeley's as the accelerator, Berkeley Skydeck at the batch 15 IPP, and got the award of the most likely to become the next unicorn. And last year, I'm very honored to get the award of Innovation Showcase at the Stanford University, Japan Society, and the Stanford University's award. And the part of angel investors is one is Tom Moss. He's a serial entrepreneur. First company is Google, and to exit currently as a member of Skydeal. He succeeded to get the fundraising from Andreessen Horowitz, specialist of the hardware side and the software side, both sides. The other is Craig Tiger, ex-managing director of the Adobe, Japan and North Europe and Asia Pacific, as a specialist of the design. And I'm a good collaboration with Autodesk, not only as a current company, but also the previous startup, the Germany, as a New Orleans, recently San Francisco, not only just event, but also the product side. And in this year, we collaborate with Yamaha Motors, especially in Tokyo Auto Salon. I will share the details later. Okay, let me share about Finalware. Finalware provides the IP and design data management platform for design and manufacturing industry, especially enterprise side. So clients, Panasonic, Yamaha Motors, Nikon, those type of companies, especially design department. About program, before the detail about the program, I'm sharing 3 graphics, the A and the B and C, It looks autonomous mobility or the supercar. Okay, how do you think? Which is a human design or generative AI design? A or B or C? How do you think? The right one is a generative AI. How do you think? Could you please right hand? Oh, okay. I think around 25%. Okay, how do you think B is a generative AI design? Oh, around 40%. Okay, how do you think C is a generative AI design? Okay, thanks. Okay, let me share the answer. Everything is depends on the generative AI. The point is so the problem is that intellectual property, design rights, and the copyright. In this timing, it is very tough. For example, when client would like to use generative AI, they're very worried about intellectual property. The reason why only output. Let me go to the previous slide. Only output. It is very tough to distinguish whether human design or not. That's the reason why it needs to solve the problems. And the total market size of the only just the intellectual property over than $30 billion problem will be happen. And one of the most famous the problem is over than 300 million. As you know, Samsung and Apple's the smartphone design program. Yes, so the design, especially industrial design, is very important. And in the viewpoint of the supply chain management, especially mass production, design IP is super important. And recently, there is several evolution about the generative AI. It's possible to make from photo to generative AI sketch, and other side is from sketch to it's possible to change as a generative AI. So once again, only output is very tough to distinguish whether human design or not. So process is super important. Even WIPO, they hear the announcement as please check the procedure. The process is very important. The US Copyright Office have the same opinion. And in Japan, Japan Agency for Cultural Affairs is the same opinion. So our solution is very simple. Design data, design contract, together by smart contract. We provide our IP and design data management platform from sketch to 2D and 3D modeling, almost all the details. And the point is 3 points. First of all, our product is legal supervised by reading the international law, both US side and the Japan side, very safety. Second is a secure data sharing platform. And third one is a smart contract technology, especially in the viewpoint of the supply chain management, transparency, and traceability. That's very important. And let me share some more detail. For example, how to use our product. This article is my writing. And okay, the point is almost all the histories from human sketch, what kind of the generative AI tool, and what kind of the prompt, we manage almost the details. And once record the smart contract, everything is the transparency and the traceability very clear. And the more enterprise use case, let me share the detail about the Yamaha Motor. This project is, okay, let's use the generative AI. Not only the design, but also the graphic to the 3D to the prototyping. In this project, only just 2 weeks, we provide over than 2,000 graphic design idea, and almost all the details were recorded by our platform. And standardly, this type of the project takes around 6 months to 12 months. Especially prototyping is very tough. But in the case of me, only 2 months, everything will be finished. First idea to the graphic design idea and the prototyping, and okay, let's prepare for Tokyo Sun. Yeah, our business model is very simple. For enterprise side, the platform fee and additional fee. Some client needs GCP with Azure as a server side as a customization. Let's get a little bit customized. But standardly, only just plugin with API is enough. And the reason why we started from design is a lower hanging fruit, easy way to penetrate other industry. So our growing strategy is from design to manufacturing and the construction and the supply chain and the creative, those type of domain expansion. Let me share among our team, especially co-founder, yes, is a professional as industry designer. First company is Nikon, and not only as a current company, but also we worked together over the 7 years. Previous startup clients are Toyota, as Honda, and Panasonic, and Microsoft, those type of companies. So we know the design and the manufacturing industry very well. But this is just ours, as thank you for hearing.
Great, thank you, Masa. Masa, why smart contracts? That means they're blockchain based, right?
Yes.
Why is the smart contract approach so important in this area?
Yeah, good question. Thank you. The reason why I decided to use a smart contract, it's transparency and traceability. In the case of the industrial design and manufacturing, sometimes no contract, only bubble or sometimes a very unfair contract. But in the case of the smart contract, everything is fair. That's the reason why I decided to use smart contract.
Okay, great. We'll come back to related points after we finish all of our prepared remarks. Ivo, tell us about Braid. The floor is yours.
Yeah, thank you very much. Yeah, I'm going to try to keep it relatively brief. But yes, initially I was asked to also talk about the prehistory of Braid. So I'm Portuguese and I'm kind of an engineer as a background, and I moved towards more theoretical computer science over the time. And I started in Porto, which is a tiny town in Portugal, then moved to Edinburgh, and then to Cambridge, this one, the UK Cambridge. And most of my focus was always on learning complex systems, especially dynamic complex systems, and trying to learn with very little amount of data. So neural networks and gigantic models are not the game there. What you need to do is try to come up with smart ideas so that you can get some sort of usable model from relatively small amount of information. And that was actually going to be crucial for what the company is doing, which is trying to basically do advanced engineering design in the most automated form possible. As you might imagine, when you think about advanced engineering, even if you think about a large company like Toyota, the number of different cars that they built over their 100 and something years history is around 500 or 600. That's extremely small. If you think about the amount of cat images on the internet being on the billions and so on, you have a harder thing to learn, a harder problem to solve, and pretty much no data. So we need to approach it in a different way. But the dream is essentially this dream of trying to automate the creation of new designs and essentially an IP factory, if you like, for advanced engineering. And one thing that we like to talk about when we mean design is basically everything. So from the computer to the silicon inside to the chairs on the auditorium, everything at some point has a human that has to think about it from a design problem. And usually humans are very good at coming to you with a large list of goals and large list of requirements that need to be met. The biggest problem is how do you jump from that list into an actual shape? And that process has a lot of trouble. One of them being, it's actually quite hard to go into a CAD program and absolutely express your idea in there, but also the feasibility tests and everything. Because of course, if you ask for a human to optimize for structural integrity, heat dissipation, electromagnetic interference at the same time, together with 14 or 15 more constraints, it's just too hard of a problem and you're going to take a long time. So our sort of baseline thesis is that the next manufacturing revolution essentially happens on design. So over the last 150 years, humans have become extremely good at making a lot of the same stuff. When you start thinking about the car nowadays, some can explain 2-3 weeks to get them fully assembled. Still takes 6 years, 5 years to design. Think of a shampoo bottle, less than 5 minutes to assemble, but the design might still be 6 months when you consider all of the materials, all of the packing conditions that it needs to observe, all of the usability stuff that needs to happen. So the design part is actually where most of the effort, especially the human effort, is placed on, but is also the one that allows you to have the greatest impact in the easiest way possible. If I have already a good design process, and I know that I have manufacturing capability in-house and my logistic pipelines in-house, can I design something that uses the same materials, uses the same manufacturing methods, just changes the shape slightly? And by changing that shape, you get all of the benefits across all of your manufacturing. So in that sense, it's a quite fast for the world of manufacturing way of interacting. And I'm going to share 2 toy examples. I cannot share the realistic things because it belongs to the companies we work with. But let's say we have a big machine, in this case, one that everyone recognizes, and you have a specific part that you want to improve according to some physical metrics. We're going to keep fairly easy here, where I say I merely want to get a bit more downforce while minimizing the drag. But interestingly, I can still manufacture with the same materials, the same manufacturing methods, and the same attachment points. And I find a new shape that has a validated, optimized flow for what I wanted. I can just bring it back into my previous machine, and I got that new performance. Of course, this is the hyper-simplified model, but this happens. You know, when you talk to a manufacturer, they make, for example, AC machine. They are not willing to change the design of everything on that machine, but they know usually what are the funnels, what are the performance limitation parts. And they talk to you and you can quite quickly improve the performance just by tapping the right spots. The other aspect is the idea of how fast can I try new ideas? And if I make the process of trying new ideas really, really quickly, then I solve a second problem of engineering design, which is the engineers meet in front of a whiteboard on the morning. After 2 or 3 hours, they know what they want to do. They spend 3 months afterwards drawing, testing, going through validation, and so on and so on. And you could argue that the actual creative process happened in that first 2 or 3 hours. And then the rest is relatively menial work. And in this case, what we do is very simple problem, connecting an engine to a muffler. I want to start from a very simple shape, because that's the shape that a CAD program would allow me to do in 2 minutes, instead of going for all the precise details of the curve. And then I simply say, give me the shape that minimizes the energy loss while not hitting anything else, right? And we can very quickly get to a solution, which again, is going to be likely superhuman in terms of performance, but not particularly surprising to a human. Interesting part is that you get that in around 10 minutes on a laptop. So now when you start thinking about how does design look in the future, well, if I try this one, my creative process now, instead of being about trying 3-5 different things, you can go into trying 1,000 different things or 10,000 different things. You can actually go through them extremely quickly and see the trade-offs much more clearly. Of course, those are kind of like trivial examples, but on the bottom, we have another interesting illustration just on the aspect of manufacturability. So it's relatively easy to solve problems if you don't care how to build them. But the interesting part for the industry is that everything that you build must be manufacturable. And all 3 of those are the same problem, just different ways of manufacturing. First one being 3D printing, and it's trying essentially to remove heat from an electronic assembly in the most efficient way possible. The second one is through extrusion of aluminum, but with no other considerations. If you actually pick it up, you cut your fingers and so on and so on. And the final one will be with all of the considerations that make it a product. So the interesting part here again, that you're caring about the materials that you use, you're caring about manufacturability, caring about all the physics that make the object functional in the way that you care about. And one interesting thing about better design is that usually you save material. And saving material is also good for performance, particularly for things that move. And by doing both of those, you're also making it more sustainable. So it's kind of an interesting aspect where the typical trade-offs of, pick 2 out of 3 and the third one sort of becomes a bit worse and not to exist when you talk about better design. So how do we do this? Of course, not with LLMs or gigantic models. We need to be a lot more deliberate in the way that we approach it. And of course, we need to have all of the information that we can that humans have already discovered. For most of manufacturing, if you exclude quite extreme forms of manufacturing, classical physics are standard enough. So just be very good at that. Mathematics, particularly in geometry, very important for both the optimization part, but also how do I define families of shapes and families of possibilities that I can search very effectively on. That's a large part of our work. And then the AI machine learning comes as either shortcuts or capturing relatively interesting corners of information that would otherwise not be present, and also aspects that are not necessarily scientific. Sometimes when you're simulating, let's say, a turbulent flow, you have multiple orders of the turbulence that you might want to care about. You don't know how many you should consider, right? So you might learn that as well. I go to like the third order, and that's enough for me to get a good enough result for the amount of compute that I got. And reasoning as well between different kinds of simulators. I can have a simple one that is quite fast to run, or a very, very complex one that is very slow to run. So as I explore my space, can I intelligently which one of those simulators I'm going to pick to run and find good solutions as fast as possible. And after you have all of that, then the rest is just translation, if you would like, in a very smart manner, from a very, very high level engineering description, which, I don't know, you talk to a satellite manufacturer, they will tell you, these are my temperature envelopes, these are the kind of accelerations that I will suffer during launch, and so on and so on. And after they have that description, you just input into our system, and we automatically translate it into an optimization mathematical problem. And then that gets translated into the physical formulation. You then translate it into the computational problem of where I'm going to run it, how I'm going to run it. And then you need to pull all of it back up all the way to getting an actual shape, automatically generated report. And human work there was limited to the ingenuity of knowing exactly what the problem that needs to be solved is, and then the final decisions between the different trade-offs that you might want to care about. And we do this in Tokyo, Shibuya. So if you like physics, mathematics, computer science, and the idea of merging them together every day and working with very smart people on all of those topics, come join us. It's a cool place. Otherwise, I will leave the rest for your questions afterwards. Thank you.
That sounds great, Ivo. Thank you. So Ivo, not to get too technical, but you're using generative AI, right, behind this?
It's a
Or
form
is
of
it more traditional AI?
we tend to pick the right tools for the right tasks.
Okay.
So it's a form of generative AI. It just might not be
Okay.
the typical generative AI that you associate with text or with imagery. Slightly different.
So how do you deal with the user interface? Because even a design engineer might not know what to do in terms of AI prompting.
So there's two sort of ways that we currently offer an interface. One is I have already an object. So a manufacturer has a CAD, and I'm just going to try to improve on it. So
Okay.
in that case, I'm just need to inform what the different parts of the CAD can do.
Okay.
The other one is kind of de novo design.
Okay.
The novel design is a lot more interesting because it's more about creating a good generator for the geometry, then searching through that. And that one at the moment, it does not have a very ergonomic interface. You need to still be quite deep on it.
Yeah. Okay.
But this is part of what we're working on.
Yeah. Okay. And why Tokyo?
Yeah, Tokyo, it's a very interesting place because we thought that manufacturing in general is quite related to Asia. Asia is a very good place to go for manufacturing. And within all of the Asian countries, it's probably one of the easiest ones to get international talent to gather, to live, and to build something special. It's also very interesting that Tokyo as a city kind of merges a lot of the cultural aspects with manufacturing, all in the same place. That's quite good for us.
Okay, excellent. And I want to say thanks for flying all the way from Tokyo, mostly to come and speak at our seminar. I know you've done other meetings this week, but we really appreciate that.
Thank you. It's a pleasure.
So, Adofaer, Steffi, why don't you tell us about what you're doing? Because this is a different world, but it's the same world.
Hello, everyone. I'm Stephy, and I'm the founder and CEO of Adofaer. Adofaer is a data-driven toy design platform that brings toy to life smarter with AI. Like, it's nearly the end of 2024, but I'm still talking about data-driven because toy manufacturing industry has never changed the past 30 years. And I grew up in a toy factory, living there for almost 12 years and not really seeing the fun side of toys, but the challenges like meeting tight deadlines and seeing how old systems making everything harder. And that makes us to change, create Adofaer. And at Adofaer, we are using new ways of designing toys to make the whole manufacturing system faster, smarter, better at handling today's challenges. And I'm going to ask, anyone can have a guess. How long does it take to finish a toy project, specifically for action figurines?
From what to what? What are we measuring?
From,
The first idea, like a drawing or something?
yeah, from 2D or having a concept, more than 6 months, raise up your hand. Okay, more than 1 year, raise up your hand. More than 1.5 years, raise up your hand. So it really depends on how professional the toy designers is. And for Japanese figurines, sometimes it takes like 1.5 years. Yeah. Okay. So what's happening now today is we are actually seeing growing demand for small orders and customized toys. This is a real challenge for supply chain because we are not set up for this. Like most of the supply chains are not set up for flexibles and fast to keep up with the new demands. So like traditional factories, we are set up for mass production and they're struggling to keep up with the new demands. So we are addressing 3 main approaches. First, to align designers and product teams and factory people to speak the same language. And I'm giving a very simple example here. But apart from this, I can make like 500 examples of this. Like designers use X color for the graphic design layer. And then the factory people, they use Pantone color to actually painting the toy. And for the printing machine, we use CMYK color system. And this is really like, so they're not speaking the same language, are actually cutting off their smoother collaboration. And the second approach is we are trying to let the user to adjust their design automatically with their budget, that we integrate budget consideration earlier to ensure that their design will not be cost overruns. For example, if a figurine that they're holding a weapon like this or holding a weapon like that, they can cost very differently by the structured designs and by how you're coloring that, and also how you're actually 3D printing that before you put it into the molding. And the third approach is, this is the approach inspired by Disney, how Disney produced successful cartoons and animations. And we are analyzing the effective elements that can help you to improve the design and making each version of toys more likely to succeed. So the basic concept for this approach is to trying to find the ROI of each toy, not just buying the IP. Because IP is very expensive by who you are, like One Piece or Hello Kitty are super expensive. So from my perspective as a manufacturer side, designs made only 20% of the effort, but it really controls the 80% of the supply chain success. And early design decisions can really change how we can flexibly produce the toy. Yeah. And that's all my sharing.
Okay, no, that's great stuff. Thank you very much. So, Hong Kong has a huge toy industry, right? I know that just about the world's biggest annual trade fair on toys is always done in Hong Kong.
Because they have the harbor, yeah.
Yeah, so tell us a little bit about how you got here. What brings you over to the Silicon Valley and what are your goals for being in the Valley?
I like today's topic is about how new design process you actually impact the manufacturing.
No, there's an interesting story outside your company.
Oh,
You're in an accelerator that is actually sponsored by a Japanese company here in Silicon Valley.
yeah.
So the accelerator's name is Moon Creative Labs. So how did you meet each other? How did you wind up coming over here? Tell us
Oh,
just how you got here.
my personal journey. Okay.
Yeah,
Let me remind this. So there's one time I was dealing with building trust with Japanese clients. That's very essential. And then I find out it takes so long. And then I book a ticket to the US the next 2 days. And then I happened to meet one of the industrial designers in the Silicon Valley. And then they were like, hey, what are you doing here? I said, I'm looking for some ventures capitals that care about both Japan and US market. And then they recommend me Moon Creative Lab. And then the headquarters of Moon Labs, they sent me to the Tokyo office for like a short period of time, staying there and restructuring what you think and how you want to do your startup. And then I come back to the PA office and stay a while. But apart from this, I also got investment from the Japanese investors.
okay.
Yeah, and then that's how I got here and then met.
Yeah, okay. No, I mean, I think that it's fascinating that you're getting investors from Japan, you're dealing with clients in Japan, and somehow they send you to an accelerator here in Silicon Valley.
What? Okay, so what we're like, we're penetrating specifically for collectible toys. So different from kid toy, it's actually kid doll toy. You can think about the toys that above play and collected by about 14 years. So I think everyone is here. It's 14 years. And Japanese toys, what I find out in the US is everyone wants it and paid double the price.
Okay, so you're actually kind of moving closer to a big market here. Okay. That makes very good sense. So all of you are involved with design, using data-driven approaches, using new technologies, and yet manufacturing is a very conservative. The makers are all very conservative. Stop sharing. Let's let everybody see the panel. I think you should probably stop sharing. So Masa, I'm gonna ask you to go first, but we'll go all straight down the panel. What you find is, how do you deal with a very conservative kind of industry when you're trying to get people to use your data management platform?
Okay, good question. As your question is how do I search for this traditional industry as a client? Okay, especially as a manufacturing design and the manufacturing industry, I think one of the most important concept is a trust as a relationship. So almost all the clients are referral from as an existing client, as a friend, as a country. Referral is very important. But of course, not only in the viewpoint of the approach of the referral, but also very simply as a step-by-step approach. First timing, just a lunch or the coffee, as a dinner. The next is the first sharing of the information of the company introduction. It takes sometimes 2 or 3 months, but after making the trust and a good relationship, step by step, those types of communication will be growing. Sometimes it takes 6 months or 1 year, but sometimes a very speed.
Okay, thank you. Ivo?
Yeah, in our case, it's a bit.
Yeah, how do you
it's
deal with
somehow
it?
a bit easier because
Yeah.
people usually come for us for performance.
Okay.
Of some form. So
They have problems and they come to you.
correct, and the metrics are generally quite clear.
Yeah.
What they want. The main thing is that we don't take it all the way to fabrication. That's still on the manufacturer side. So we tend to agree on what is their simulation platform that they trust. So even though we use our software, we end up having to validate in the end in something that they feel comfortable. Because they know that if they get, I don't know, 11 on something in that software, after they go through their manufacturing process, they get a 9 or a 10.
Yeah.
Right, so they know that transfer, they don't actually even want to tell us that transfer. So we agree with them, termination point at where they feel comfortable that they can take steps. And it's usually good enough for us, but I think the main issue that you find is being a software company serving, let's call it hardware, in this case, not computational hardware, is that the timelines are very different. So for them, a quick start for a next project might be, 6 months down the line.
Right.
So you
That's a
sort of
quick
have,
start.
that's a quick start because they have much larger cycles than a typical
Yeah.
software company would have. So in our case, we need to keep a lot of leads open at all the time and understanding that sometimes you don't hear from them for like 3 months, 4 months. It doesn't mean that they are lost. It just means that they're waiting for the next sort of iteration point. And you need to just be patient on those cases.
Okay, I have a follow-up for you. So you can specify any number of different kinds of goals that people would have, like design for manufacturability
Mhm.
or reduce the cost. Or, you had mentioned environmental sustainability, right? How are you seeing the kinds of goals? What do you think people really care about now?
So architecture, especially large scale architecture, is going a lot more towards sustainability and carbon footprints.
Uh-huh.
The rest is quite happy with just baseline cost savings.
Right.
Because that's, if you reduce the amount of aluminum, your impact is also reduced quite dramatically. And a few of them are on performance points. And performance is either something very critical for the company, meaning if they don't get that, they lose that segment.
Yeah.
Or it's just part of new companies. We work a bit also, actually, one of the last public projects was a flying car. So just a gigantic drone that carries people. Or the Osaka 2024.
Okay,
And in that case, it's mostly feasibility aspect, right?
Yeah.
So as they designed, they saw that some things needed to be improved. They just needed the performance in order to be able to go for. We discussed a tiny bit and found a way of getting there. But there's a bit of, the limit of physics, of course. I cannot make an airplane weigh 200 kilograms and carry 7,000 people.
Right.
It's just not going to happen.
yeah,
So usually with clients, we need to manage expectations slightly. Humans have been optimizing for quite a long time. And when they think, oh, AI, okay, I want like a 50% cost reduction. Probably not
Yeah.
going to happen tomorrow on a screw, right?
Yeah.
But it's an interesting conversation almost always.
okay, thank you. So Steffi, you've got kind of a different problem. Here are toy manufacturers and here are people who are doing like manga and these kind of characters and designs and so forth. Those would be totally kind of new customers, new suppliers upstream for the toy manufacturers, right? Do you have trouble getting the toy manufacturers to do something different than they have been doing?
Yeah, definitely. At my position, I'm more like a bridge between the people who do business and the people who actually producing it. And for the manufacturer problem is how do you, so for manufacturer people, especially the manufacturing is low end, labor focused. So there's nothing fancy there. And then what they want is more deals, more revenue, and how do I increase the power to negotiate with them to give me smaller order and give me speak to the market, because that's what Japanese customer care about the most. And on the other side, for the company who want to do the toy business, you may know they're all from creative industry, not like, I would say 90% of them, they don't have toy designers. And even the professional toy designers from Mattel or Funko, they don't really see how a toy is made. So they really stop at the design with 3 views, but they don't know how they design. So they always have to change because budgets go super high. Imagine the mangas from Japan and anime from Japan. The characters inside, they can fly. But how can you make a flying characters for physical stuff? There's many negotiation and costs, like educational costs to teach your clients on that.
Yeah, so, you know, you were talking, the different kinds of color standards, right, that the designers use and the manufacturers use and then the printers use. Was a very powerful example. So I've got one more question, then we'll open it up to audience questions. So you're all engaged in kind of international business. And I'm curious, Steffi, you've been here since this summer, right? Or when did you arrive in the Silicon Valley?
20 days of November.
Okay, so what has been different than you expected when you got here to Silicon Valley? And what's been the thing you've learned since being here in Silicon Valley? And this is going to happen for Tokyo, and it's going to happen in your kind of world travels too.
What's so different here in Silicon Valley is there's a moment that we raise me a thinking that you can change something with the industry. So our slogan for our company is actually tomorrow or today. So we want to really change the industry by how we set up the industrial standards from the start with the design. And then that can go impact the supply chain and backwards with the design.
Okay. All right, good.
Because now they are not.
Yeah. Do you think Silicon Valley is easier to get people on the same page?
With founders, yeah.
Okay, sounds good. Ivo, so what was the big surprise about trying to do things in Tokyo?
It's reasonably bureaucratic, but if you follow all of the steps, regardless of whether they make a lot of sense or not, it gets done. So the process is usually strange for almost everything, from creating your physical seal that's then you need to register and use on every piece of paper. But if you go through everything, you get it done. Also, it's extremely cool.
Okay, well,
You can have most of your life taken care of you very easily from very good food. And it's not that expensive of a city. And while your focus building is actually quite nice. In terms of the startup environment, it's actually surprisingly international. Lots of people that are thinking about Tokyo, lots of investment going into there. The government is becoming way more open in the last 10 years or so, and really trying to make it a much better place for startups. At the moment, of course, the scale that completely different from US to Tokyo, and the level of maturity is also different. The market, and particularly manufacturing in Japan, is quite gigantic. Very interesting.
Okay, so Masa, you've got Singapore in the middle.
Yeah.
Between Japan and here, right?
Yes. So yes. Yeah, there are sort of differences. But once again, I lived in the Singapore 3 years, and not only just living, but also managed the subsidiary as Indonesia, as Thailand, and Malaysia, those type of countries. But almost the differences between the USA and Singapore and Japan, in the viewpoint of the finance of the technology, I think the Silicon Valley is the best. Totally, I not only just but also angel investor and venture partner of the venture capital totally in Japan. In that viewpoint, Silicon Valley's ecosystem, especially finance, is amazing. Only just in the viewpoint of the hardware startup or the design startup, variation is totally different. This is the first one in the viewpoint of the finance. But in the viewpoint of the manufacturing, Tokyo and Singapore is very good. To be honest, really, the Singapore manufacturing and the Tokyo, the manufacturing level is very high. This is the second one. And the third one is the differences of circumstance, especially sales and marketing. In the case of the business side, maybe it depends on the places, but the stance of the fight, as I'm number one, those type of the presence is very important. But in the case of the Japan, very step by step, the trust type of the communication is very important. In the case of the Singapore, the fact and number, very simple, black or white. Only just 15 minutes, 20 minutes, almost of the deal will be done. This is the difference is my feeling.
Okay, thanks. So for those of you who are watching on Zoom, if you have a question, feel free to use the raise hand function on Zoom. And we'll take brief questions by audio. So it's up to you whether you let us see your face, but use the raise hand function so I know that you've got a question. For now, I see a question back in the back here in the auditorium. Go ahead.
Richard, for inviting those amazing speakers and speakers. So I have like one question. The first question would be, so I think like for generating generative AI and come up with those kind of paintings, like most people will tell like it is created by AI at the first sight. So what do you think that is the reason cause this phenomenon? And is it possible, like kind of potential ways for us to optimal the like the kind of system that we can just, like do it?
Say that one more time. I think we're getting the general idea, but AI still isn't completely natural, right?
Actually, like, lots of paintings that we can directly know that they are from human, and some for AI, we can directly know that they are from AI.
Yeah.
So, but I mean, like, sometimes people do not like the feeling of strong AI. We really want AI to come up with some like new human art here so that we can, appreciate that. So I mean, what do you think like cause the kind of phenomenon that AI can only create AI-like artwork? And is it like a potential way for us to solve that problem, like update the system or debug whatever? Is it possible?
So yeah, the limits of AI right now, especially generative AI. Masa, you go first on that.
Yeah, okay, good question. I think first of all, the stance is very important. I know I use a lot of the generative AI tool, the design 2D and 3D as a movie. But the most important point is human creativity and how to expand human as a possibility. The AI is just a method as a tool. So the case in the viewpoint of the in Japan, the copyright, it depends on the human creativity. Only just the AI made a design, it's not possible to get the copyright. So for me, to think about what kind of the approach is good for human creativity, it's the most important thing. And technically, of course, to record almost the detail. For example, this is a human sketch, this is the AI, and what kind of the procedure, the percentage, those type of the expression is possible. But the most important point is the stance. It's my answer.
So if I can follow through on that, I think in the US too, if AI completely generates the design, it cannot be copyrighted.
Yeah.
Only human inventors. So that puts a limit on how much you can use AI and what you're doing, right?
Yeah, and the additional comment is in the viewpoint of only just sharing the idea. For example, the two finalists prototyping or the final design, before the sharing the idea, for example, the not only one or two, but also 1,000, 2,000, in this case, very useful. And in the case of the prototyping, especially the 3D printing or the mold or those type of the method, in that case, it's a little bit tough to use current generative AI. It takes a lot of the GPU or the power, but just the graphic design is a very useful method. My comment.
Thanks for that. I have an add-on question. So, I mean, like Japan is like has a huge anime industry.
Yes.
So they are created by like, I mean, paintings, joys, whatever. So, I mean, do you think it's possible for AI to be a author, like for anime, whatever? Is it possible, or is it like still already like some like kind of projects AI like created on anime, whatever?
Very, very good question. Yeah, it's but first of all, technically, it's possible. Some creator has already started to make anime or the manga by a generative AI, technically. But 2 point. One issue is intellectual property. In the case of the generative AI, some tool is there's a risk of the intellectual property, especially manga or anime. Only just a one shot. Oh, this is very similar to a famous manga, but this is very similar to famous anime. That's a problem. This is the first one. And the second one is the circumstance of the culture. In the case of Japan, for anime was a manga, very, how to say, very high interest and high attention for those types of quality. So little bit, only 10% and 5% is very similar to, oh, it uses generative AI, blah, blah, blah. In this case, very sensitive. Please check the SNS, Twitter, X, the Instagram. Also, the anime or the manga similar to, or this is related to generative AI, blah, blah, blah. It's risky. The product design and industry design, no problem. That's that. In the case of the anime and manga, as I think this culture differences a little bit high. My answer.
Ivo, in regard to what you're doing, you're using AI to improve designs or to do de novo design, and you have to get people to accept it.
Yeah, so it's actually quite interesting. So in some performance applications, people actually welcome the, let's say, not human aspect of the final design. It just looks cool and new. Other cases is also that the majority of the machines that you have around you, most of the parts are inside and the user never sees them at all. But there's also a case for aesthetics. If you're talking to a company like Ferrari and they ask you for new seat design, they care about all of the performance aspects and the lightweighting and stiffness and so on, but they also care that it looks like a Ferrari seat.
Yeah.
Right. And this is one of the cases where we go more into the traditional generative AI, but it's mostly on the attempt of capturing the style that the company is looking for, and then providing essentially a balance between the performance and the style that was. And that in the end ends up with like some form of Pareto front between style and performance, and we present it and the client eventually picks where they feel comfortable.
Okay. Steffi, are you worried that we're going to have so much AI generated designs that it's just going to be a flood and so there'll be second-rate toys out there?
Actually, generative AI for toy designs. For toy, you have to really think about how does it look at the back. For many anime, they are 2D. So cartoons, they're 2D. So some of our creators, they are asking, I want to use the AI to really see, help me imagine how it looks like at the back and at the sides. Then you see in the anime characters or game characters, but it goes to the toy, it's different shape. So it wouldn't be really one-to-one how it looks like in the anime. So it, like, imagine like Funko Pop toy. It's like characters, but you go onto the products, it look different, but it's a toy. So.
Okay, thank you. So thanks for your question. Next question. Steve, go ahead.
Hi, my name is Steve Spencer. I'm a second-year graduate student here at Center of East Asian Studies. My question is for Ivo, specifically because you're located in Shibuya right now, but Japan has had a recent increase in defense spending. They've jumped from 1% to 2% GDP and are continued to increase or projected to increase for obvious reasons that don't really need to be mentioned in here. Have you had any military clients or government clients or even companies that are looking to get into the dual use, both commercial and military industries, come to you for these AI upgrades?
The answer is yes, there's interest. As a company, we try to apply those projects at the moment.
Okay.
Also, we see ourselves very much in the stage of a deep tech company where we want to validate that all of our ideas work really well, but not necessarily searching for a massive amount of revenue at this stage. We just focus on the tech.
Okay. Is the reason for avoiding kind of military-centric jobs simply because of the negative optics associated with that currently, or?
Yeah, there's a certain philosophical stance of the people in the company.
Okay.
But also there's really not the necessity to engage with those in order to do very, very interesting work regardless.
Okay.
At this moment. So no need to make, let's say, harder choices. At this point. We mostly focus on if I have a new kind of physics I want to test on or a new kind of generated for a specific manufacturing method, I can always find a client with whom to get a realistic problem and to make sure that our tech works.
I have one more question, if that's okay, Professor.
Okay, go ahead.
It's for Steffi here. So you talk about collectible toys. From my understanding, a lot of the collectible, the reason they're collectible is because they have a big name behind them. I'm thinking Disney Sum Sum, Duduma, the Disney Duduma thing that you showed earlier, Beanie Babies, you know, stuff of that nature. How difficult is it for these small scale toy manufacturers or toy design companies that are trying to work with to penetrate into that industry?
So
Actually, I think I should give a little bit of kind of background in this. So somebody's going to make a toy based on a character. They have to have permission from the rights holder to the toy, like Disney or whoever, to actually make that physical thing. How do they do that?
Okay. So normally, we call Disney or Hello Kitty Sanrio. It's the IP company. Then they go up to, they rent it out for the licensing. So people want to do the toy business or merchandising, they borrow, they rent it, they pay for the licensing, and then they're able to produce it.
So is it really difficult for the producers to get that license? Or are the IP holders generally pretty happy to have more revenue?
This is a very different culture between Japan and the US. If it's Japan, it's very easy. You can get the IP as long as you pay. This is like the culture is encouraging to rent the IP. It's very multicultural. But in the US, it's really like a monopoly thing. So really like a big company can borrow from.
Okay, thank you.
That's interesting. That's kind of like the opposite I would have expected. Yeah, okay, other questions? Go ahead. Go ahead, you first.
I'm Eric, first year master's students in the Center for East Asian Studies. My question's towards Masa.
Okay.
So your company focuses on optimizing existing products, if I'm understanding this correctly. What percentage of a product do you need to start using generative AI for the optimization process?
Actually, that's more for Evo, I think.
Yeah, I think it's I would cover that.
So you're doing data integration.
So after Carl and spoiler.
No.
Oh, yeah.
Oh, my bad.
Sorry, can you
So
can you
Evo, why
repeat
don't you go ahead?
just one more time? What's percentage?
Yeah, so like what percentage of the final product do you need for you to start the optimization process? Are we talking about you're only using existing product?
Okay, so yeah, it depends, right? Some companies already have a specific part within an assembly, right? And let's say it's an assembly with 150 parts. They don't want you to redesign the whole assembly. Yeah. That would be too much of an undertaking. But let's say on a AC assembly, they care about the heat pump and they care about certain heat dissipation aspects and so on. And you just need to talk to them and understand how far you can deviate from that initial design. Usually they are very happy if you can stay within the same geometric envelope that the part was occupying before. Sometimes they tell you, okay, there's a bit of space if you need to grow something out of your part, that makes sense. But it does depend quite a lot, but typically you have a starting point. De novo designs tend to be way more close to kind of startup environment where people want to build, again, a new flying car, or they want to build something completely new. And in those cases, yes, sometimes we do studies that are really very, very little initial information. I just need to solve this generic problem. But in terms of cost reduction, it tends to be more the second type.
Do you think that's going to limit innovation in a bit?
Yeah, I mean, they have a business, right, generally, and you're trying to improve their business, and they don't want to necessarily completely rehaul everything that they've done in the past, right? There's an initial kind of idea of first pilot and so on tends to be relatively conservative. Second one, they ask you for a complete crazy magic trick because it's like, okay, they got excited about the progress that you made on the initial problem. Now they want something impossible. But at some point, they just become a bit more aware of, okay, how much can I push beyond typical human design? But it also depends on the maturity of the company. Some companies that we found, even though they had close to monopolies on the particular thing that they were doing, they were not using even a simulator. They were literally just manufacturing and testing in real world. And then the process takes, 9 months or so. And they tell us, okay, we tested 4 different concepts in these 9 months, very proudly. And then we do 10,000 in a week. Okay, it's a different way of thinking about how to solve problems. So there's an initial educational step where after they start seeing the different way of doing things, they also start thinking differently about what they might be able to do. It goes both ways, and not so much that you have like, please do this specific thing for you.
Thank you.
So I'll do a quick follow-up with Steffi. So of the kind of designs that you're converting into toys, do you think most of them will be prompted from text into some Gen AI, or do you think that there will be existing characters that are owned, somebody already has IP for? What's going to be the big market, do you think?
So from our product building,
Yeah.
at the first stage, we're trying to cut off the prompting. Yes, why? Because we, at the very early age, we focus on the companies with IP.
Okay.
So if we IP, they will upload with the picture or models.
Okay. So that solves a lot of that. That takes care of that problem. With regard to the data sharing, Martha, the kind of whole platform for managing the data behind design, are you seeing the industry really changing to a more data-driven approach? Or is this something where you've got still what I would call the early adopter market, and then the massive manufacturing is still kind of AutoCAD?
Yeah. I think, yeah, AutoCAD, those type of technology, are a lot of the possibility. The reason why, as before the generative AI, the AutoCAD, those type, for example, Autodesk, those type of company, very approach it to the generative design. In this case, as a very advanced technology will be a step by step as a growing. In this case, a new market will be happen. That's the reason why, in the case with the AutoCAD, those type of technology, there's possibility.
Okay, thanks. I had a question from way back here. Weren't you, wasn't it you? Yeah, go ahead.
My name is Alex. I'm a junior undergrad. Last summer, I was actually working with 2 Japanese VCs in Tokyo, and both of them are pretty international. One of them was like kind of American Japanese, and the other one Chinese Japanese. So and I was also able to meet a lot of foreigner founders in Japan. So this question is, I guess, more for Ivo and Steffi. How do you guys think how friendly, how like foreigner friendly is Japan right now for foreigner startup founders, especially in the tech sector?
Which direction? How California friendly is Japan? That's your question, right? Ivo, you start.
Well, they're improving. Okay, they have. I think the whole VC market in Japan is smaller than Miami by itself. So if you think it's the 3rd largest economy in the world, VC is still very small for that. In terms of the conditions for founders as a person, it's easier to get a visa, and you get a much nicer visa if you're employed by someone else than if you are employing people. So it doesn't matter if you're paying salaries and so on, you get fairly bad visa conditions. But beyond those two, it's an interesting and welcoming environment. You still have a lot of VCs that will not speak very good English. And that limits a tiny bit what you can access, especially if your Japanese skills are not great. But besides that, all of the events are quite open. There is a bit of a division between, let's say, the more international ecosystem for founders and the more Japanese ecosystem for founders, and they tend not to mix that much. But also the characteristics of the companies that are in both sides are also quite different. So people that are doing very localized services or very localized kind of SaaS and so on that never even have the ambition of leaving Japan. So have their own kind of circle. Everyone that does a bit more deep tech or a bit more transformative things, they always have the dream of going international. But it's definitely getting a lot better than even 5 years ago.
So Steffi, in your world, what's it like? Because you've got Japanese IP holders, you've got big Japanese clients that want to produce things. How friendly are they to somebody coming from outside?
I can share my personal story here, starting with this hall. So in early of April, I was like joining one of your session, talking about.
Oh, but
Yes,
here, okay,
yes,
one of our
in the
seminars.
same hall.
Yeah,
Talking about different Asian market, like comparing China, South Korea, Japan, India, the venture capital market and development market. And at that time, like before joining the session, I was literally in Japan for 14 days. And then I don't feel much about global personally. But after that, I fly back to Japan and stay another month. And then suddenly everything for the talks and for discussion, everything is Japan to global, suddenly change. I thought I still remember the graph that you posted on the PPT. It's like every Asian country is like that. Everyone wants to develop, and then in Japan they like that. And your conclusion is like everyone goes. And I fly back to Japan for a month. And yes, I can see the attitude is actually embrace to go global. And then I find out when I talk to my IP companies, you know, as a foreigner and talk to the IP companies is really a disadvantage because I'm Chinese, and then they're afraid that you're taking their 3D models and everything, like doing, you know,
yeah,
big toys.
gonna steal our IP, yeah.
Yes, and but I changed the way how I actually talk to them. I
Okay.
said, because like Japanese people, they really want to go out, but they don't want to. So I said I would take it out
Okay,
with the toy business.
so I've got a question from Zoom for you, Steffi. And it has to do with how your platform coordinates the supply chain at each step in the manufacturing process. Oh, this, you know, you've got somebody making the toys, but then you've also got the materials coming in and also you've got to distribute after.
We are not doing that part yet. We're focusing on the design, prototyping, and then definitely we will have to do with the supply chain management thing because it's cross-border supply chain. No matter you are going to produce that in Vietnam, India, or China, it will eventually a cross-border business. And then I'm not going to go into how we can do in every step, but we're trying to make sure that we don't have to fly over to China to pick the color,
Oh,
to check, to do the quality control. And we're trying to do something with the Vision OS that people can actually, the quality.
yeah,
Yes.
okay, great. We only have time for a couple more questions. You go first.
Sure. I'm a VC investor focusing on consumer industry before, and we're actually investing in a toy company before. And you know, like it's very interesting. They're getting IP from Disney and like Hello Kitty stuff. So my question is for Steffi. Actually, I really love your idea of like integrating all the stakeholders, right? They talk to each other in a more efficient way, but you know, like they work in very different like manners. And so I want to know more details about how you actually make that happen. Like, who are your clients right now? What kind of things you actually do for them to make the communication more efficient? Because you say you are a AI-driven data designing platform, but like the things I heard right now is more about the designing side. What is the AI part, and what is that going to be in the future, maybe?
Let me also preface this. When did you launch? This year, right? So really been only commercial this year.
Yes.
Go ahead.
I like the questions. That's also how I see companies, like how I evaluate actually AI companies to see how much they're doing the non-AI stuff, right? So my background and my co-founders, we're cousins, and we live in the factory for almost 12 years. And I was so shocked after I left IBM. after IBM, I was in a robotic companies doing the lawn mower. And I was so shocked staying 3 months in the factory that how come you guys still using emails? And then how come you guys like pointing out designs and changing that? And then even the clients, our clients are, by that time is the IPO company, one of the very successful companies in the US. And apart from this, I'm actually working with Real Madrid Football Club. And then they're trying to do small orders, but for each players with more version of toy. And we're gonna do all in one for them as a package. Yes, because they are very new to the toy market.
Okay. Let's move on to another question. Go ahead. You had one, right?
Thank you for the presentation. My name's Harrison. I'm a second year in the undergraduate School of Engineering. And so when I worked in Sendai at Tohoku University this past summer as a research consultant, I worked with many companies, large tech companies that were interested in using generative AI, but weren't necessarily familiar with different aspects of generative AI and how it works and what can be done with it. And so the question I had was, when working with your clients, how, if you were able to gauge it at all, did you notice any specific trends or associations with both familiarity or understanding of generative AI and the types of requests that you were given?
Let's make that a little bit broader. Ivo, you can answer that as it is. Ivo, but Martha, I've got a kind of variation on that for you.
Yeah, I mean, they have a certain expectation from AI, and the expectation is lack of precision and lack of ability to make things that can be built. So most of their experience is, okay, I went into generic models on the internet. Some of them can generate a 3D model, but zero physical guarantees, zero manufacturability guarantees, zero even assembly procedure guarantees. So we do have to tell them that, like, we are slightly different. You know, you're gonna get a proper simulation with all of the physical data there. You're gonna get the proper design with the manufacturability that you required, and so on. And at some point, they just don't care about how you're gonna do it. It's one of the beauties about advanced engineering is performance and manufacturability kind of trumps pretty much all the other aspects. But also, as we make presentations for them, and they get this idea that now maybe instead of having a final meeting that I'm going to discuss 3 designs that my R&D developed, I can look at an actual, distribution of all the designs and pick which areas are of interest for me, and then explore those further, and so on, so on. They start realizing that the design process can be very different, and they get quite excited. And the next step is, how can they get that capability inside of their company? Because one thing for them is, okay, I got a really good design for a problem I had, but I'm going to keep having these kind of problems going forward. So how can I kind of bring it in? And that's the second part of our discussion is how do we get into their pipeline and make sure that they sort of substitute the creativity bit, but not necessarily the validation and so on that happens afterwards. Most of the engineers just feel like instead of having an idea and then doing sort of not boring, but repetitive work for quite a long time, they can explore the ideas. It seems a much better proposition for them.
So really, all 3 of you are asking people who've been involved in a function, manufacturing that has, 100 years of tradition. And you're asking them to kind of change a little bit about how they've done the front side of the manufacturing process, the design getting into manufacturing, the data management getting into manufacturing. Do you think the change is going to stay? Do you think that, Masa, I'll ask you first, and this is kind of the last question for everybody. How do you see the industry manufacturing 5 years from now? Will everybody be comfortable with AI? Will they be doing things in a different way? Will the idea of smart contracts that use blockchain just be absolutely, expected, or do we still have a long way to go?
Yeah, let me answer from my side. The previous startup, once again, as to the additive manufacturing and the machine learning startup. In that startup, we made the platform for 3D printers, several toy, or the jewelry, those type of things. The idea was not bad, but the opportunity point was very simple. It's a 3D modeling. Almost all the people didn't have the skill of the CAD or the auto diffusion or those type of things. But in the case of the generative AI, there are lots of possibility to drive how to make a 3D modeling. In this case, it's possible to expand the human creativity and productivity. So 4 or 5 years later, I think there's a lot of possibility about this manufacturing industry. Everyone can make it their own as a design, as a business, very easily. Of course, the final decision will be depends on the professional designer or the professional person. So in short, 4 or 5 years later, I think there dramatically the change will be happened in this industry. That's my opinion.
I'm gonna kind of change the question because I got a great one coming in from Zoom. This is it though. You see mass customization and rapid product changes really something that is just going to take off now. Everyone's talked about that in manufacturing for years. And whether it's garments or toys or, you know, you said democratize manufacturing today, right? And I'm really curious, we're going to see this take off within the next 3 to 5 years. Okay, Ivo, 3 to 5 years.
I think on advanced engineering, it's gonna become a lot shorter, but it's still a long enough time to build something significant.
Okay, Masa?
But it depends on the situation.
Yeah, okay.
Yeah, that's yeah. Not only mass production, especially prototyping, it will be more growing.
Yeah.
Especially as everyone knows the additive manufacturing, especially 3D printer.
Yeah.
In this case, more easy to especially as a prototyping and almost all the technology, especially as generative AI, those type of the adaptation for the prototyping very rapidly. I think.
Right. So we have some refreshments outside. Remember, everybody, next week is Zoom only. Same time, but we don't have the auditorium, so next week is Zoom only. In the meantime, join me in thanking the speakers one more time.